Alright, why is phenol a stronger acid than cyclohexanol? Well, if you remember, whenever we have an acid, and this is all acids, when they bump into water, we are just going to simply see the loss of H's and making the H3O. So we want to look at what happens to phenol that's different than cyclohexanol when that H comes off. All right. Well, when the H comes off cyclohexanol and just makes this cyclohexanol ion, that charge kind of has to stay there. There is no resonance contributor that can move it in. I can't move it into this next one because that carbon can't take anymore. But on phenol, the nearby pi systems are a great place to dump some of those electrons. So we lose that pair of electrons, or we lose that hydrogen and leave the electrons behind. And what we're going to see happen is those electrons move into the ring. Now, it's going to do that by dropping in and making a double bond here, which causes this guy to move up. Those pair of electrons can't stay there because the carbon can't make more than 4 bonds. So we end up with a double bond there. That oxygen now is nice and stable. It was negative before. These 2 bonds are still right where they are at, but we have a pair of electrons that have moved to just this one location, making it a negative charge. Now all we're going to do to show the other ideas that's going on, we're going to do that same thing again. That pair of electrons is going to move and make a bond there, causing these 2 to come up here to this location. That stays like that. We have a double bond here. The other double bond's still there, but now this location is negative. And we're going to do that once again. This pair makes a double bond here, causing this to move up there. Now, none of these are necessarily stable. They still have a negative charge, and we will find that it prefers to stay on that oxygen because the oxygen is more electronegative. But all of these can exist, increases the stability of that O negative.